this video is for discovering pre-algebra, or discovering Algebra 1, Part 3, where we talk about radicals and exponents, and this is for worksheet 3-3. So today we're going to be working on this one just to kind of review the quotient rule. This has to do with the quotient rule. The quotient rule says that I can turn this in, I can break it apart. Okay, so I can say the square root of 4 and the square root of 49, or over the square root of 49. I can break that radical up into division, okay? And that means that I can now solve it because the square root of 4 is 2 and the square root of 49 is 7. And the same with this one. I can go square root of 7 over the square root of 81. Now the square root of 7 can't be solved. That's just going to be 7, square root of 7. But I can solve the square root of 81, that's 9. And that's all I can do. I can't break down that 7 any further, not until we start getting calculators involved. This one I'm going to have to add a little bit of product rule to it. Let's tackle the bottom first because it's easy. The square root of 121 is 11. The top is a little bit more difficult. I'm going to break it up into a squared times a. Use that product rule and split it up into different multiplications. All right, now I know what a squared is. It's just plain a. But I can't do anything with the other one, so it just stays as a root a. Or let me put it this way, the square root of a squared times the square root of a. It's kind of tongue twister-ish. So that's just going to become an a square root a over 11. Again, I can break this up into top and bottom. And for this one, because there's a lot going on, I'm going to do the top and then do the bottom. All right, so this one's easy. The square root of 100, we should know that it's 10. On the bottom, though, we have two different things that we are breaking up. So we're going to have to break it up into root 4, and root x squared. Root 4 is pretty easy. It's 2. Okay, the square root of 4 is 2. The square root of x squared, well, these cancel out. Remember, square root and square, they're opposite operations. They can cancel each other, leaving me just with the x. So on the top, it seems like what I have is 10, and on the bottom I have 2x, but I can reduce these, okay? I actually have 5 on the top, the 2 completely reduces out, and an x on the bottom. All right, so on the top of this one, I have 9x. I'm going to split that up into a 9 and into an x because I know that 9, the square root of 9 is perfect square, and that answer is 3. Can't do anything with the x, so there's my top. Now on the bottom, I have the square root of 16. Well, that's a perfect square. We know the answer is 4. So 3 root x over 4. 3 more, you guys. Okay, I can break up the top into 9x over x to the 4th, and I could do radical 9 and radical x squared, radical x squared. I'm going to break up that x to the 4th into 2x squares, okay, because now everything's perfect. 9, the square root of 9 is 3. The square root of x, that's going to cancel out, just giving me just an x. And again, I can another cancel, giving me just an x. If I get those together, 3x squared is my answer. On the bottom, though, I got a lot more work on my hands. I'm going to break that up into 24 and into x. And the only perfect square that I can see in there is going to be a 4, so that's 4 times 6. So square root of 4, square root of 6, and that x. Okay, I can do the 4, that becomes a 2. These can't do anything with them, so it's just 6x underneath the radical. So the bottom is going to be 2 square root 6x. I can't even reduce anything. Nothing is reducible. So I'm done. All right. I do want to state that if you've learned how to how to rationalize the denominator, you could have rationalized the denominator in this one. I usually do that on a later worksheet. I usually say that little skill till last to teach. So if I've already gotten to it before you start doing this worksheet, you can rationalize the denominator or stop right there. I'm stopping right there because generally I don't do that till a later worksheet. Okay, so let's do the top. So I have the square root of 16, the square root of a squared, and I have one more a. Okay, the square root of 16 is 4, the square root of a squared is a, and I can't do just a. So my top is done. My bottom, on the other hand, 8, the square root of 8a squared, I know is going to be broken down into the square root of 4, square root of 2, and the square root of 8a squared. Square root of 4 is 4. Can't do anything with the square root of 2, but a squared, yeah, that's a. So I get 4a root 2. Well, guess what? These two can cancel. 4a and 4a can cancel out. And again, we haven't learned how to rationalize the denominator, so we're just going to leave this as the answer. In a later worksheet, I apply that skill. All right, so I know probably 4 can go in this 20 times. Let me think about 16. I think 16 can go into 80 as well. I think that's 5. Let me double check that. Yes. So 16, which is a perfect square. So the square root of 16 and the square root of 5 for the top. Square root of 16 is 4. Can't do anything to 5. If I do the bottom, the square root of 9 is perfect, so that's a 3. So my top is going to be 4 square root 5, and the bottom is going to be a 3. Might as well just leave it improper in this case. All right. Very good. Keep working this until you feel good about it, and I will see you in class, everyone.